Okay, let's talk about what we call the depth versus time kind of graph for pouring in water or draining water out of certain containers. Okay, there there are different shapes that can be given to you. But if you do this kind of questions, right, you must read carefully the question. So they simply ask you, oh, this is a container, and then I pour water inside the container. Then how will the depth or the height of the water vary with time? Okay, then you just think about it. This is a shape with vertical walls. Now, when the walls of the container is vertical, it means that every 1 second, it will fill up the same height of water. Okay, so let's say 1 cm in 1 second, then in 2 seconds it will be another cm, there will be 2, so on and so forth, and that's why it is a straight line. Okay, so when I fill in water into containers with vertical walls, the speed of the increase of depth is actually the gradient of the graph, okay, or the line or whatever. So don't you agree the gradient of this line is constant? That means the speed at which the height is increasing is constant. Every 1 second I go up by a certain amount. Okay, so for vertical walls container, the line will be a straight line. Okay, it makes sense. You must get your basics right. It's about the increase in height every second. Okay, so the gradient actually represents the speed at which it's going, and a simple way to think of it is this: when it's constant speed, it is like that. Okay, a straight line. But when you have a container where the walls are not vertical, okay, it is in this shape. Don't you agree that when you fill in water, the space that you need to fill, okay, as time increases, it's always like that. You read graph like that one, okay? As time increases, as this quantity increases, what happens? The space that you need to fill up, right, will become smaller and smaller. That means it is not like that. Like that means constant speed. That means the rise in water will be constant. But this one is going to get faster and faster and faster. Okay, so it's going to be like that. Faster and faster and faster. Okay, then this kind is where when you fill in water, at first, wow, very fast. But then because as time passes by, you need to, as the water goes up, right, you need to fill up more space. So it's not constant speed, but it is the rate at which the height is increasing is getting slower and slower. They don't come down like that. It's going to be like that. Okay, it's going to go up, but it's not going to U-turn. Okay, so I hope that's clear. And then finally, right, this kind is the same as this. It's a little bit more complicated. Next time you'll learn at high level, but it's about the same. At first fast, then as time goes by, right, slow. So this kind, you have to actually draw respect to all these critical points. Okay, so this part here will be slower and slower and slower. Okay, because a lot more to fill, right? Then later, as you go up, less to fill. So then faster and faster and faster. Then this one, right, is constant speed, so it's a straight line from here. Okay, make it smooth. Alright. Now, this is the basic concept. Now we do some real questions. So if it's like that, I think it's very clear. It's just like that, right? Okay. This is pouring in water. Water going in. Later, I'm going to show you water going out. Alright? How about this? I pour water in. At first, constant speed here, right? But this constant speed is slower than this one. Huh? That means this is like that. Constant speed, right? Until here. Okay, must take note, this one must stop at this particular checkpoint. Then after that, they will change already. Is it going to go faster? It's going to be constant speed. It's going to be a straight line because vertical wall, right? But the gradient will be steeper. Then you stop here. Okay? So I hope that is clear. How about this one? At first, very fast. Very fast. Okay? Until here, the checkpoint. Then later slower already because it's going to take more time to fill it to a certain height. So it's like that. Okay, now next. This shape is going to get, you see, it's not vertical, right? It's not vertical wall. It's going to be faster and faster. So it's like that. Faster and faster. Until here, the checkpoint here. Then after that, it's going to be a straight line. Why? It's a vertical wall all the way until here. Finish already. Don't go beyond. Okay, under the water will overflow already. The height won't increase anymore. So no, don't have this. Okay, then the last one. This is a checkpoint. Remember that, because there is a change in the pattern beyond this dotted line. Okay, here also there's a change in the pattern, and here of course that's where you stop. Okay, so for this, it's going to get slower and slower, faster and faster because less space to fill, and then after that, constant speed. Okay, so that's how it goes. And I mentioned just now that this is water in, right? What if it is water out? Water is coming out. Very simple, okay? Not say very simple lah. Most people can't see this immediately. So I recommend, if it's a question on water out, you do water in first, and then the water out, right, is just a flipped version of this. And then after that, you just erase this. Okay, so it's just like that. My end point here is my start point. My end point here is my start point. So it's like your physics reflection. You understand? So you must why is it like that? Okay, later I tell you why is it like that. Okay, then like that, right? Straight line here, and then the one is a curve. Okay, please use a ruler when you draw straight line in the exams, because if you don't use a ruler, use freehand, they won't give you the marks. Okay, so it's a mirror image. Can you see it's a mirror? It's as if there's a mirror here. Like that. Okay, yeah. So why is it like that? Okay, let's maybe take this example. If I were to start with the water here, then I poke a hole here, right? So at first this is full of water. Then I poke a hole here, water will drip out, right? But at first, when time t equals 0, it's at the maximum. That's why you see, all these are at maximum height. See, all these are at maximum height, maximum height, maximum height. Then the water is going to decrease until it becomes 0. Okay? I was here, right? Okay, then maximum height, and you will go at first very slow, because why very slow? Because we're trying to get rid of the water here. We're trying to measure the height, this whole height, right? So we're trying to get rid of, that means when you pour water in, you start here. Water in, you start here, right? Water out, you of course start here. So there's a lot of water to get out. That's why it's slower. Then later faster like that. Okay, faster means steeper, slower means gentler. Okay, so in summary, when you have a vertical wall, okay, vertical wall of the container, it's constant speed. That means the rate at which water is going in or out is constant speed. It's getting faster and faster, faster and faster. You can also see from your concept of gradient, right? This gradient is getting more and more at each point, right? So it means that speed is faster and faster, lor. Then this will be slower and slower. Remember, don't U-turn, it's going to go like that. So it's slower and slower. Okay, hope you understand.